Hi all. Now we're going to see about finite automata in compiler design. Finite automata. It is a state machine that takes a string of symbols as an input and changes it accordingly. Finite automata is a recognizer for the regular expression. When a regular expression, a string is fed into the finite automata, it changes its states for each a literal. If the input string is successfully processed and the automata reaches its final state, it is accepted. That is, the string just fed was said to be a valid token for the language in the hand. The mathematical model of finite automata consists of five different tuples. We call all these five symbols as tuples. First one, it is Q. Q that represents the capital Q that represents the set of states. Next is summation symbol that represents the set of the input symbols. Next Q0 that represents the starting state. QF which represents the final state, and finally the del, that is a transition symbol. This represents the transition function. All these five tuples combinedly define the mathematical model for the finite automata. L of R be the regular languages are recognized by some finite automata FA. So we have some several states. First one, it is the states. State of a finite automata are represented by the symbol circle. So the transition diagram will be represented using these following symbols. So state has been represented using the circle symbol. The state name can be written inside the circle. Next, the start state. Start state. This is also represented using using a circle, but before the start symbol, before the circle, an arrow has been appointed. This represents the start state of the automata. Next is the intermediate state. All the intermediate states have at least two arrows, one pointing to and another pointing out from them. Final state. If the input string is successfully passed, the automata is expected to be in the final state. The final state is represented using the symbol a double circle. In a finite automata, we may have any number of final states. That is, even the starting state can also be the final state. That is, it can be represented using double circle. But the main condition is that we should have only one state as a starting state. Next is the transition. The transition from one state to another state happens when the desired symbol in the input is found. Upon transition, automata can either move to the next state or stay in the same state. It depends upon the input that has been given. Movement from one state to another state is shown as a directed arrow, where the arrow points the destination. If the automata stays on the same state, the arrow pointing from state to itself is drawn. This is the one example for how we represent a state. Here Q0, this is the starting state because we have an arrow in the previous state, a small arrow. So this is the starting state. And QF, which has been represented using a double circle, that is called as the final state. Here for the state Q0, we are giving 1 as our input. While we give 1 as our input, it goes from one state, that is from state Q0 to QF. So it reaches the accepted state. Now from the state QF, while we give a 0 as an input, it goes back to Q0. So this is a transition. This is what we call as transition. So this is how we transfer from one state to another state. Now we'll see an example for how the state does not changes when we give some input. For example, with the same structure, when we give 0 as an input for the state Q0, it stays the same state. So this has been represented using a self loop. And for the state QF, when we give 1 as an input, it stays the same state. So that is called as a self loop. So this is how the transition that has been occurred in the finite automata. And now we are going to see about the types of finite automata. There are two different types of finite automata. That is the deterministic finite automata and the non-deterministic finite automata. We will see all those things clearly in the next class. Thank you.